This is Griffin from the Math Learning Resource Center at Villanova, and this is the second video in our Trig Tricks series. And in this video, we're going to determine the sine of pi over 12 without a calculator. Now, I just want to note down a few things before we begin here. So, in general, you're not expected to know by memory the sine or cosine of pi over 12. But in general, in most scenarios, you are expected to know the sine and cosine of the following three angles of pi over 3, pi over 4, and pi over 6. And sometimes they might give you a unit circle, but most of the times they won't, because these are the sort of standard angles that show up all the time that you're expected to know the sine, cosine, and tangent of. Well, if you know the sine and cosine of these angles, then it follows based off of the identity tangent is equal to sine over cosine, tangent of theta is equal to sine of theta over cosine of theta, that you know the tangent of that angle as well, if you know the sine and cosine of these angles. But anyways, let's assume that we do know the sine and cosine of these angles. Then how do we rewrite sine of pi over 12 in terms of sines and cosines of these three angles? Well, we can use the angle addition and subtraction identities. Now, you might be wondering, how in the world are the sine and cosine angle addition and angle subtraction identities going to come to our rescue here? Well, check this out. I'm going to make the following claim. I claim that pi over 12 is the difference of two angles in the collection of angles pi over 3, pi over 4, and pi over 6. That is, we can rewrite pi over 12 as the difference of one of these two, or as two of these three angles. We can rewrite pi over 12 as the difference of two of these three angles in this group here. Pause the video and think about how we might do that. So I'm assuming you've had a go at it. So pi over 12, check this out, pi over 12 is equal to pi over 4 minus pi over 6. Well, let's see why that's true. Let's make a common denominator here. This is equal to 3 pi over 12 minus 2 pi over 12. If I multiply pi over 4 by 3 over 3 and pi over 6 by 2 over 2, that gives me 3 pi over 12 minus 2 pi over 12, which is equal to pi over 12. So that's nice. So this means that sine of pi over 12 is equal to sine of pi over 4 minus pi over 6. And check this out. We can use the angle subtraction identities here. And if you don't remember the angle subtraction identities, that's okay. You can either look up a trig identity reference sheet online or in your textbook, or you could rederive it using the technique described in our video on the angle addition and subtraction identities. You can rederive it each time you need it using that technique. So I'm going to assume that you've already rederived it, or that you've looked it up in a trig identity reference sheet. So remember that the sine of alpha, or not remember, I'm assuming you've looked it up or rederived it, the sine of alpha minus beta for any two angles alpha and beta is equal to the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So check this out. Check this out. We can say that pi over 4 is our alpha, and pi over 6 is our beta. So this means that sine of pi over 4 minus pi over 6 is the same as sine of pi over 4 times cosine of pi over 6 minus cosine of pi over 4 times sine of pi over 6. And we know, based off of either looking up the unit circle or just by memory, that the sine of pi over 4 is square root of 2 over 2. The cosine of pi over 6 is square root of 3 over 2. And we also know that the cosine of pi over 4 is square root of 2 over 2. And the sine of pi over 6 is 1/2. And this simplifies to the square root of 6 over 4 minus the square root of 2 over 4, which is equal to the square root of 6 minus the square root of 2 all over 4.